Okay, we're going to finish up your January 2012. Now in number 33, they ask that you graph this exponential equation. It fits right into your y equal. They want you to use this restricted domain. So when you put that in your y equal, you only need the numbers from your domain from -2 to +2. Those are the only numbers to put in there. Be careful that this part, this is your exponent, x plus 1. Let me write this. This is your exponent. Then down here is the -3. Put that in your graph and pull out the values in your table. These are the values that you're going to plot. So plot each one of those points. And just connect right in between here. That's the only part that they want. And there's your answer. Number 34 gives us a circle. It gives us the center, and it gives us an endpoint on the circle. From the center to the endpoint is your radius. So the equation for your circle, and we've been seeing this a lot, if you don't know this, put this on your formula sheet, where h and k is the center, and r is the radius. So you've got your center, this is your h and your k, but you need the radius. To find your radius, you can use your distance formula. Now, your distance formula for your radius is going to say the difference in your x's squared plus the difference in your y's squared, square root of that. You can absolutely set this up using this point. Either one can be the x1, y1. And we'll set this point as your x2, y2. And just substitute this in. You want the distance for your radius. So you're going to substitute them in, and be careful with your negative signs. You can actually just put this whole piece right here in your calculator. Just don't put the radical sign. This will give you 9 plus 4, and you are radical 13. This is your radius. When you plug this into your formula, don't forget you're going to square it. Another nice way to do a distance formula is Pythagorean's theorem. Drop a triangle like this. There's your 3. There's your 2. There's your 9 and your 4 after we square it. So 2 squared plus 3 squared equals r squared. 4 plus 9 equals r squared. This is all you have to put in to your formula. So we're going to set it up. X minus a -5 squared plus y minus 2 squared. And we already know your r squared, 13. So just resolve this part. And there is your formula for your circle. This is a nice one. Here's your special right triangles. It's asking you for a triangle with a 60 degrees. Well, you know your 30, 60, 90, or you should. Now, with a rational denominator means you have to rationalize any radicals in your denominator. So cosecant is the reciprocal of the sine. The sine is your opposite over your hypotenuse. So your cosecant is going to be your hypotenuse over opposite. So here's your hypotenuse, 2, over the opposite of 60, which is radical 3. Remember, this is your reference angle, 60. Now, don't leave this with this radical. Rationalize. Multiply the numerator and the denominator by radical 3. And this is the answer that they're looking for. Don't pick up your calculator on that one. Now remember, as the problems go up in points, they require a little bit more work. So here's a 4-point problem. And it calls for you to show plans for a cell phone tower. Here's your tower, and it's perpendicular to your ground. And a guy wire, which is attached here. And another one from here, from 100 feet away. Okay, you've got 2 guy wires. Now, the nice part about this is, and I'm going to erase that so it doesn't get in the way, is you've got 2 triangles, actually 3, one here, and the big one. And you're trying to find the height of the tower, this guy right here. Any triangle you look at, you're missing a point. So the first thing you can do is find any missing angles. You know the sum of the triangles, the angles in a triangle add up to 180. You know supplementary angles add up to 180. So find this guy by 180 minus 65. In this triangle, 32 plus 115 from 180 gives you 33. In this triangle, 65, this will give you 30, this will give you 25. So you are able to find all the angles of your triangles. This way, in case you're looking for something, you will spot it. Now, both of these triangles share this side. So if I can find this side, then I could approach this triangle and be able to find x. So I'm looking for this. Let's call this y. So I can set up my angle and my side opposite. And notice this. If you didn't find 33, you wouldn't have found it. So I have the law of sines. 100 over the sine of 33, is equal to, this is my y, over my sine of 32. Cross multiply and round this out a little bit. They're looking for the nearest foot, so round it here, and then at the end we'll round again. Now if it helps you, put it here. So now in this triangle, you can see this right triangle. To find x, we can use just a plain sine. Opposite over hypotenuse. You could also use your law of sines for this, because the sine of 90 is 1, so it's okay to use your law of sines as well. It will work out to be the same. So resolve this and remember to round to the nearest foot. This is a nice little log problem. You have to find eventually the value of y divided by x. So x is here. Use log equals exponent, because a log is an exponent. It's the inverse of the exponent. The base of the log is the base of the exponent. There's your exponent. Equals x. Put that in your calculator. So now you know what x is equal to. Let's do the y. Log equals exponent. The base is y. The exponent, negative 3/2, and it's equal to 125. Now, in order to solve for y, we need y to the 1. 1 exponent. That's how you solve your equations. Y to the 1 equals something. So we're going to multiply, raise this guy up, multiply this to its reciprocal. because when we multiply those, we'll get 1, and that's what we want. If we raise that side to that power, we have to do the same to this side. So this is going to give us y to the 1, and you can absolutely put that in your calculator or use your reciprocal and know that it changes it to the positive. It's the cube root of 125 squared, so it's going to be y is equal to 1 over 25. Now you can finish the rest. X divided by y. 32 divided by 1 over 25. Put it in your calculator, or keep, change, flip. And this will be equal to 800. You had a couple of things to do here for your logs. Here's another nice question with your regressions. But remember, with your regressions, you have to show work. They're looking for an exponential regression. You're going to put this in your L1 and your L2. Show them that you're using L1 and L2. Give them the steps you used. Stat, calc, whatever number that happens to be, exponential regression, L1, L2, by 1. Now, remember, all your values have to be rounded to the 10 thousandths. This is 4 decimal places. So we're going to put it in and come out and round. And if you round in your calculator in your y equal, it's actually easier to round there. And if you go to use your table, you will have to round there. And don't forget your x. This is your x up here. Now, the second part of this is part A. I like to label these so you don't forget. Part B says, using this equation, predict to the nearest whole number at the end of the 18th hour. Hours is your x value. So show the substitution. You're going to show y is equal to, just list everything back out. Show the substitution. You have to show work. If you don't show work, you're not going to get credit for this problem. I have a technical difficulty right now. Hopefully it's coming back. There it goes. So 1.1509. Oh. Still in my technical difficulty. And raise this to the 18. Make sure that exponent up here is 18. Then give them your answer to the nearest whole number. 341, it should be. Having a heck of a time here. There it goes. 341. Okay. And I think we have one more. This is usually the big one. This asks you to perform the indicated operation. The multiply gives you one great big line, but the divide says flip. So I would rewrite this first and take the reciprocal after that divide. Then you can make this as one big line. Now, your goal is not to cross out terms, but to factor and reduce. So if we go to factor this first part here, you notice that they do not have anything in common. So we're going to group. Out of this first group, anything with 4, you can try grouping. We're going to factor out an x squared. We're going to get x minus 3. We want this to be x minus 3. Notice we're going to factor out a 6. So we get x squared plus 6 times x minus 3. Let's put that right here. In the denominator, not so bad, we can factor out an x. Remember, this is one big line. In this numerator, factor out a 2. In this denominator, their highest is x cubed. Factor out the x cubed. And the last numerator is the difference of perfect squares, 4 minus x, 4 plus x. And this denominator, trinomial, x plus 4, x minus 2. Now, from top to bottom, you can cancel out your like factors. Notice you have an x minus 3. Get that out of here. We also see an x minus 2. Get that out of here. I'm left with an x plus 4, and I do see my x plus 4 up here, commutative property. And what's left here is an x minus 4 and a 4 minus x. Notice they're exactly opposite signs. So if I factor out a negative 1 out of either one of them, I will make a match. Now I can take out the x minus 4. Circle that negative 1 so it doesn't get lost. So you are right now left with your x squared plus 6 up on top, and your 2, we took out this, and your negative 1. So negative 1 times 2, negative 2, and x squared plus 6. In the denominator, we took everything out except this x and this x cubed, which we add the exponents, the x to the 4th. And that is how you leave it.